From building a railway in the unforgiving heat of the desert to upgrading a research station at one of the coldest places on Earth, and from the biggest infrastructure project in the Himalayas at heights of up to 3,700 meters to one of the largest man-made holes in the world, here are the world's most extreme construction projects. And this is number 5, the Rothera Research Station. Built in one of the most remote and hostile places on Earth with temperatures ranging from 5 to -40 degrees Celsius is where the United Kingdom is currently building a $415 million megaproject. Everything you see here, the workers, equipment, and construction materials had to be shipped from the United Kingdom to Antarctica, a journey of roughly 11,000 kilometers. But what exactly are they building here? This place serves as the largest British survey station for polar research and houses many ongoing science projects in partnership with the Netherlands. One of these science projects is the real-time research on climate change. For this purpose, the Antarctic weather and fauna are constantly being monitored in order to create precise climate change models that can predict the rise in sea level. Over the years, more and more buildings were added to facilitate efficient research work despite the extreme weather conditions. What was once a small base for only 4 people is now a complex for up to 130 staff, operating full swing during the summer months. For about 4 years, the British government has been working on the most expensive state-funded project in Antarctica since the 1980s, the so-called Antarctic Infrastructure Modernization Program. And part of this $415 million project is upgrading the Rothera Research Station. Most of the buildings on this station were no longer in the best condition and needed to be renewed. Besides that, a new $55 million wharf was completed in 2020 to accommodate the new polar research ship. Also, construction on the so-called Discovery Building started and is expected to be finished in 2024. The Discovery Building is a new science and operations facility that features more energy-efficient systems to minimize the environmental impact of the station. The 2-story building will combine field expeditions, medical facilities, and office spaces, and replace a number of older buildings. Number 4. The Etihad Railway Megaproject. From the ice shelves and frozen seas, we now take you to the sand dunes and the relentless heat of the Arabian Desert, where the United Arab Emirates is currently building the Etihad Railway. Once finished, this $11 billion megaproject will connect the United Arab Emirates to Saudi Arabia through a 1,200-kilometer-long network spanning from the Guwaifat region of Abu Dhabi to the Fujairah port on the east coast. This huge infrastructure project, however, is just a tiny part of what the members of the Gulf Cooperation Council, Bahrain, Kuwait, Oman, Qatar, Saudi Arabia, and the United Arab Emirates, have planned for the future of their countries. Since all the GCC countries heavily depend on oil, their economies took a hit during the 2008 financial crisis and the COVID-19 pandemic. To overcome this, the GCC states are now all working together on a long-term solution with a massive $100 billion rail network to better connect their ports and industrial centers. This will allow them to further diversify their economies and eventually become less dependent on oil. But let's take a closer look at the UAE's Etihad Railway megaproject, which poses special and extreme challenges, as it runs through one of the hottest and most ruthless regions in the world. During the day, the heat can reach up to 50 degrees Celsius, so construction workers are forced to work at night at a relatively low 30 degrees Celsius. The extreme heat, however, isn't their only problem. Since the construction site is located in the middle of the desert, you naturally have to deal with a lot of sand. During strong winds, huge amounts of sand can settle on the construction site and make work impossible or even damage the railway. Therefore, the nearby sand dunes are slowly transformed into clay. This process, however, takes years to complete. Another quicker solution to fight the sheer amount of sand is to plant lots of trees near the railway. The trees can then act as natural walls and prevent the railway from being covered in sand. The Etihad megaproject will be built in 2 stages and should be fully operational by 2024. construction of the first stage began in 2009 and consists of 2 tracks with a length of 264 kilometers from the Shah and Habshan gas fields and the port of Ruwais in the west of the United Arab Emirates. The railway should also help the country to reduce its carbon footprint, which is among one of the worst in the world. A single train journey is equivalent to removing approximately 300 trucks from the road, which reduces the carbon dioxide emissions by 70 to 80% compared to using the trucks. Phase 2 of this project will add another 600 kilometers to the rail network to connect the East Coast and other key industrial regions. Number 3. Norway's new coastal highway. Let's move on to somewhere where the climate is more pleasant. Norway is famous for its beautiful landscape and its vibrant coastal towns, towering mountains, and steep cliffs. But such a stunning landscape comes with immense difficulties when it comes to traveling through the country. Currently, a trip from Trondheim in the north to Bergen in the south will take you about 21 hours and requires no less than 7 ferry rides. To improve this slow connection to the cities in the west and north, and thereby also boost the economy, Norway now finally decided to solve this problem with a $47 billion highway upgrade. This highway will be the first of its kind once finished, and will include floating bridges, floating tunnels, and the deepest road tunnel in the world, the Rogfast Tunnel. The Rogfast subsea tunnel is the first of the crossings, with construction starting in 2018 and initially scheduled for completion by 2026. However, cost overruns have now delayed the project to at least 2031. With a depth of almost 400 meters below sea level, the 30-kilometer-long tunnel will become the world's longest and deepest subsea tunnel. However, the most ambitious and difficult phase of the whole coastal highway megaproject is probably the Sognefjord crossing. The reason being that the Sognefjord is the deepest and largest fjord in Norway, with dimensions of over 37 kilometers in width and a whopping 1.3 kilometers in depth at its lowest point. The challenge associated with the Sognefjord crossing includes its massive dimensions, as well as the large number of ships that enter the fjord frequently. As a rule, every crossing should allow for a clear shipping lane of no less than 400 meters wide, with 70 meters clearance above sea level and no less than 20 meters clearance below the sea level. Putting all of these in mind, the project team came up with several ideas for this fjord crossing. The first idea is a standard suspension bridge with a 3,700-meter crossing. A bridge that long needs support towers that would be 450 meters tall, much higher than the Empire State Building, and, if built, would become the tallest bridge structure in the world. The second idea for the Sognefjord crossing is the construction of a floating bridge. This would also mean that the bridge might need to be raised to allow ships to pass. This would prove seriously difficult for the engineers, since the bridge would only be tethered to each shoreline. There is also a concept of a submerged floating tunnel. Due to the extreme depth of the Sognefjord, the tunnels would be suspended from floating pontoons, which would allow ships to easily pass above. Possibly, the solution to this problem is a hybrid concept, which would combine a floating pontoon bridge and a portion of the submerged floating tunnel to allow easy passage of ships. If this idea is implemented, it would be the first of its kind in the world. Number 2. Tibet's high-speed railway. In the middle of the incredible nature of the so-called roof of the world, China is building one of the most extreme railroads ever. The Tibetan Plateau has an average altitude of more than 4,500 meters and is surrounded by the world's tallest mountains, including Mount Everest on the border of Nepal. At the moment, they are working on an 1,800-kilometer-long electric high-speed train from Tibet's capital Lhasa to Chengdu. The project is divided into 3 sections, and 2 of them were already opened. For the railway from Lhasa to Ningxi alone, almost $6 billion were spent. This 400-kilometer section features 41 tunnels and 121 bridges to compensate for the altitude differences. Due to the enormous heights, the trains are equipped with unique technology, including a system for oxygen supply and special windows to protect against the high UV exposure. However, the most difficult part is still ahead of them. Construction of the more than 1,000-kilometer-long middle section between Ya'an and Ningxi began at the end of 2020. The area is also known for frequent earthquakes as the Indian and Eurasian continental plates collide here. Landslides, snow avalanches, and floods are not uncommon in this region. In addition to that, building on the permafrost ground of Tibet, which expands during the winter and shrinks during the summer, had to be avoided. To build a railroad under these conditions is extraordinary, and therefore around 90% of this line runs over viaducts or through tunnels, making it a very costly project. Over 100 temporary medical facilities were scattered along the rail to provide prompt medical interventions for the construction workers. In addition to the challenging altitude, which makes the work exhausting, the workers also have to deal with immense temperature differences. Inside the tunnels, they can reach up to 45 degrees Celsius, but outside, the temperature is often 30 degrees Celsius lower. The whole project is expected to be completed by 2030. Once it is finished, it will make it much easier to access this breathtaking region, and it's a major step in China's plan to improve the country's infrastructure. And now, let's continue with number 1, Diamond Mir Mine. The last extreme construction project on our list is the Mir Diamond Mine in the Siberian region of eastern Russia. Siberia is well known for its harsh and long winters, with average temperatures well below 0 degrees Celsius. Not many people live in this ungrateful environment. Yet in the 1950s, Soviet geologist Yuri Kabardin went on an adventurous expedition into this remote region of Siberia. Many similar expeditions have failed before him, but Yuri managed to discover diamond-bearing deposits. Today, exactly where Yuri first found diamonds lays one of the deepest man-made holes, an open-pit mine more than 500 meters deep. To give you an idea, this mine is so deep it could fit the Eiffel Tower, the Empire State Building, or even the Lakhta Center, the tallest building in Europe, inside of it, and there would still be some space left. Diamond mining began in the late 1950s, but the hostile weather conditions made it almost impossible. Winters can last up to 7 months, making the materials brittle, with temperatures reaching below minus 30 degrees Celsius and even freezing the oil of the machinery. As a result, the miners had to use explosives to melt the permafrost in an attempt to reach the diamond deposits. At night, the entire mine had to be covered to prevent the machines from getting damaged from the extreme cold. The summers weren't great either, as the ground turned to mud. All buildings had to be built on piles, otherwise their heat would melt the ground and worsen the mud problem. This soil was too unstable for the main processing plant, so it had to be built on safer ground more than 20 kilometers away from the mine. In August 2017, unfortunate hydroecological conditions led to a massive water inrush that completely flooded the mine. Of the 151 miners who had arrived on the midday shift, 143 were rescued. The search for the remaining 8 miners was unfortunately abandoned shortly afterwards. Mining is still carried out in the Mir mine today, but the whole operation has moved underground. What do you think about these extreme construction sites? Let us know in the comments below.